Hi, this is Prasanna from Vivek. Welcome to Matlab Basics Edition. In this video, we are going to discuss how to work with matrices and arrays in Matlab and how to do array indexing in Matlab. Now, we'll straight away move on to the Matlab. In the command window, I'm going to create a row vector as well as column vector first. So what is a row vector? Row vector is nothing but it is a vector which consists of one row with n number of columns. Similarly, if it is a column vector, this consists of n number of rows with one column. This is called as row vector and column vector. Now we'll see how to create this row vector and column vector using Matlab. Let me take a variable name as A. If you want to create a row vector, that should be mentioned within a square braces. Now let me take some random values. Let be 3. Once the value is over, you have to provide a space. 3 space 4 space 5. So this is a row vector. If you hit the enter button, you can see the output is A is nothing but it's a 3, 4, 5. It's a row vector. Just go to workspace variable, double click it. You can able to see that it consists of a row vector which contains one row and 3 columns. Similarly, if you want to create a column vector, let me take b is equal to, you can take some random values, 6. If you want to take it to the next row, then you have to use a semicolon, 6 semicolon 7 semicolon 8 semicolon 9. So this will create a column vector. Just go to the workspace. You can see this consists of 4 rows and 1 column. It's a column vector. Then if you want to create a n cross m vector, that is very easy. Take C is equal to, now I'm going to create some 3 cross 3 matrices. It's a random matrix. Let it be 1, 2, 3. I want this 1, 2, 3 to be on first row. If you want to take it to the next row, then you have to use semicolon 4, 5, 6, semicolon 7, 8, 9. Type enter, which will give you a 3 cross 3 square matrices. Just go to C. You can see this spreadsheet consists of a square matrices which contains 3 rows and 3 columns. Okay. Similarly, you can study with zeros and ones of matrices. Let me take, first of all, I will clear my screen. Now you take that A is equal to zeros of 5, 1. So here, it's a 0 is a inbuilt function of Matlab. And this is nothing but it is an argument. The first value of argument represents it's a row number. The second value of argument represents it's a column number. Therefore, this matrix will produce a array of 5 rows and 1 column with all zeros. Similarly, you can take P is equal to ones of 5, 2. That means it will produce 5 rows, 2 columns of all ones. C is equal to ones of, suppose if we give only one argument. So previously I used 2 arguments. One is for row and one is for column. If you use only one argument, then it will be considered as 4 rows and 4 columns. Similarly, you can study, let me take D is equal to, if you type simple ones, it will produce 1 without any argument, without braces, without argument, it will give you ones. Similarly, E is equal to zeros, it will give you 0. F is equal to ones of null argument, which will give you again 1. See, ones of without any argument also 1. Ones of null argument is also 1. And ones of 1 will give you 1. Ones of 0 will give you null set. So this is the way you can learn the Matlab. Okay, so these are all the basics of arrays and matrices. Now we'll move on to matrix and array operations. So we know that how to do addition, subtraction. So in this video I'm going to discuss only some very basics of array operations like a matrix multiplication, row wise multiplication, column wise multiplication, element wise multiplication. These are all the things I'm going to discuss today in this video. Let me clear. Let me take some random matrix. Okay. So it's a 3 cross 3 matrix. Now what I'm going to do is, let me take B is equal to A plus 10. So A is a matrix, 10 is an integer value. Now I'm going to add this 10 to the A matrix. So this value will be added in the each and every value of matrices. Okay. Suppose if you want to take a transpose, what is transpose? All the rows will be converted into columns. All the columns will be converted into rows. Let me take C is equal to, I want B transpose. It will give you transpose. If you look at this, 22, 23, 24 is a row that will be converted into column. It's a transpose. Then how to do inverse? Mathematically, if you want to do inverse, let me take, I want A inverse. If you want A inverse, you need to know what is 1 divided by determinant of A as well as adjoint of, that is multiplied with adjoint of A. Or you can take a cofactor of A transpose. But in Matlab, that will be done by with a single step. We take D is equal to, you can use INV. It will give you the inverse of matrices. INV of, let it be I want C, inverse of C. Yeah. So now you see this, the resultant matrix D is not a matrix of integer values. Actually, Matlab stores the numbers as a floating point values most of the time. And the arithmetic operations are actually sensitive to small differences. That's why it is giving me the warning signal, matrix is close to singular or badly scaled. The reason is always matrix calculates the matrices in terms of floating point values. Okay, so now we'll move on to matrix multiplication. Let me clear my screen. Let me take a random matrix. A is equal to, let it be, it's a 2, 3, 4, 7, 8, 10, 11, 12. So I took some random matrices. Now I'm going to multiply it. I want B is equal to A multiplied with A. So always, so we know that the if you want to do array multiplication, there are two types of multiplications. One is row by row method. Another one is row by column method. This Matlab will always do row by column method. You can check it out. This is the row by column multiplication. If you want element wise multiplication, take C is equal to A dot multiplied with A. So this dot represents, it is a element wise multiplication. That is, 2 is multiplied with 2, 3 is multiplied with 3, 4 is multiplied with 4. That means it will take, actually it's A square. So 2 square is 4, 3 square is 9, 4 square is 16. Such a way it will calculate. You can see it. A dot will give you element wise multiplication output. Now if you want D is equal to, if you want any power values, A dot cap power 3. It's a square, A cube matrix. Just now we calculated A square. This one is A cube, A power 4, A power 5, whatever the value you want, we can go through. That means A power 4. Actually 2 power 4 is 16, right? So this is the way you can study the things. Next, we'll move on to array concatenation and then array indexing. We take the same A. Okay. With the help of command history, I took the value. This is the A matrix. There are two types of array concatenation. One is horizontal concatenation. The next one is vertical concatenation. Concatenation is nothing but it's not adding, it's a merging of two array. If we take B is equal to, within a square braces, I have to use A, comma A. A, comma A will give you a horizontal concatenation. This is called horizontal concatenation. See, this consists of 3 rows and 6 columns. Similarly, if you want to concatenate in vertical manner, then C is equal to A. If you want to take it to the next row, you have to use semicolon. A, semicolon A. Now you see this. This will give you 6 rows, 3 column matrices. So, comma will perform horizontal concatenation, whereas semicolon will perform vertical concatenation. Okay, so keep it in mind. These are all very good inputs. Now we'll move on to array indexing. So let me take some random matrix. A is equal to now I took a 4 cross 4 matrices. So from this 4 cross 4 matrix, we'll discuss how to do array indexing. There are two ways you can represent a particular element in array. One way is, let me take B is equal to A of 2, 3. So here A of 2, 3 is nothing but it is an argument. This 2 represents it's a row value, 3 represents it's a column value. So what I want is second row, third column value. It's 90. Second row. So this will give you 90 as an output. It's a second row, third column value. So this is called a conventional indexing. One more type of indexing is called, you can use a single subscript. So whatever we used in the earlier case, I used 2 subscripts, one for row and one for column. Let me take C is equal to A of 10. If you use like this will also give you the same output. See, this is also giving you 90 as output. Then how it is working? This kind of indexing is called linear indexing. Linear indexing. So how it's actually working? It will start from the first element. It traverses down the each column. It will find out the value. So A of 10, right? It will start from 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th value is 90. This is called linear indexing. You can use a single subscript. Suppose if you use C is equal to A of 17, definitely this will give you error because it is out of bound. There is no 17th value. Okay, it's exceeding the limit. Totally, actually, it is a 4 cross 4 matrices. Totally 16 elements are there. So you can give up to A of 16. Okay, let me clear my screen. I'll take the same A matrix. This will be the A matrix. Now, whatever I did, I'm going to do the same thing. So listen. Let me take B is equal to, or it means B is equal to A of 4, 5. Actually, this will give you error because the first argument represents its row, second one represents its a column. Actually, there is no fifth column in my input. Definitely, this will give you error. Index in position 2 exceeds array bound. Index must not exceed 4 because I am having only 4 rows and 4 columns. But if you use the same A of 4, 5 on left hand side, let it be it's A of 4, 5 on left hand side. So now I am going to assign some values. Let it be it's a 91. This won't give you any kind of error. So instead, it will create a new column because it's a fifth column, right? 4 rows, fifth column. That particular element value is 91. It will create a new column and 91 is assigned in the last value. So what you can came to know? Exceeding the bound on right hand side will provide you error. Whereas at the same time, exceeding the limit on left hand side will give you a new vector. So you must be very careful where to assign, either on left hand side or right hand side. It must be very clear. Let me clear my screen. Now we'll discuss how to pick a particular row, particular column from the matrices. Let me take A, the same A. Now I'm going to pick only these values 2, 5, 9 from the matrices. There is a third row, first column, second column and third column values. I don't want one actually. I don't want this one. I want only 2, 5, 9. How to pick these things? Let me take B is equal to A of, the first argument will be it's a row actually. So I need a third row, 3, comma. The second argument is column argument. So you have to mention first row, second row and third row. So I want from first row to third row. So in the last video I discussed about what is the usage of colon operator. So if you wherever you use column operator, the first value will be the start value. The second value will be the end value. So this is start value, this is end value. You can refer my previous video. This will give you 2, 5, 9. If you want the entire row, you can use 1, 4. Instead, you can use C is equal to A of, if you want entire row, 3, comma, colon. You need not to mention the start value and end value. So if you mention only colon, that means that it is starting from 1 to final value. This will also give you 2, 5, 9, 1. Similarly, if you want to take a column value, example, if you want 1 or 2, 1 and 12 as a column values, you can easily do it. Let me take D is equal to A of, first is a row, okay. So it is starting from 2 colon 4 comma 4. This will give you 102 112. This is a way you can do the array indexing. These array indexings are very important concepts if you are doing a very big programs. I hope that this video will give you a clear idea of how to work with matrices and arrays in Matlab and how to do the array indexing also. Thank you. Kindly subscribe to the channel. If you have any queries, please drop a mail to this mail ID. Thank you.